My name is Jonah Kowall. I'm one of the maintainers of the Jaeger project, and I'm here to walk you through a little bit about Jaeger is. How many of you don't know what Jaeger is? All right, that's pretty good. So I guess maybe there's a couple people. I'm going to probably go over some things that are familiar to many of you. And then I'm going to drill into some of the really exciting stuff that we released just before the last KubeCon in the US, which is Jaeger V2. It's a very big multi-year effort that I'm going to talk about the reason why we did it, the benefit to all of you. And then I'm going to talk about some of the other things that we're working on and the roadmap and kind of where the project's going. So with that, my name's Jonah. My day job is that I run product and design at a company called Paessler. We do infrastructure monitoring. You may have heard of PRTG. That's our product. And then my not day job, I work on OpenSearch. I'm part of the technical steering committee, and I'm also a maintainer of Jaeger, so that's my volunteer job. And when I'm not working, that's where I'd rather be, underwater. I spend a lot of time diving. I live in South Florida and dive all over the world, so that's what I like doing. That's my passion. These are pictures from the last year, but I'm always taking new pictures and stuff. So let's talk a little bit about why we all need and love distributed tracing. I'm going to get into a couple of different demos, and I'm going to show you what Jaeger does in the basic demo, and then we're going to dig into what it does with monitoring capabilities, so deriving metrics from traces. And then we'll dig into Jaeger V2, the architecture, some of the changes, and kind of why we did it. And then we'll have time for questions. I don't really have a clock, but I'll keep an eye. So distributed tracing is really important because we all build microservices architectures. We have lots of different teams, and everyone is pointing at each other when there's a problem. So the issue that we try to solve with tracing is, you could say whose fault is it, but where did it break, why did it break, and most importantly, who can fix it so that our customer's back up and running. And tracing gives you that unique ability to answer those questions and to get really deep into what's happening in your code. So that's why it's important. We can also do other cool things like build dependency maps. I know our dependency map's a little ugly, but you'll know in the roadmap that's going to change. We're doing a lot of work right now on dependency maps and visualization. And then, of course, we can do root cause analysis. So tell me about that customer transaction. What was the issue? And then the other benefit is that we can derive metrics and monitor SLAs, understand availability, error rates, things like that. So the basic tools that we use are instrumentation, how we get the data out of your component, software, application, how we collect that and store it, and then how we visualize it and allow you to analyze it. So those are kind of the main basic things of tracing and data collection. So for those of you that don't know OTel, considering you all know Jaeger, this is probably a little redundant. A trace is the end-to-end transaction, and that can have multiple spans, which are basically components that are being called within it. Inside each span, there are tags, and those tags allow you to either understand instrumentation that injected the tags or for you to add your own tags. I was just talking to someone earlier at the Jaeger booth that said, we have a bunch of different teams that are generating traces. How do I tell them apart? And I said, well, you could just have the team put a custom tag in there that says the team name, and then you could filter and do all kinds of fun things with the traces that are related to the team. So tags are really powerful, and they allow you to do a lot of extensions on the data model that's part of tracing. And then you can kind of visualize these. You know, this is a lot of work in ASCII, but the right-hand side is more of our familiar timeline, where time goes across, and then we see the spans cascading down. But another view is more the topology view, where you can kind of see the tree and how things move. And then there's lots of metadata attached to each of the spans. So these are kind of the basics. Let's jump to a live demo, my favorite thing, at least it's local. So we have an application you can install on your own called Hot Rod. And Hot Rod is supposed to emulate Uber, and Uber created Jaeger. So this is like a mini version of Uber, where we can basically dispatch cars. So I'm calling this, call to these different places, and all of these are generating a bunch of different traces that are hitting a bunch of microservices. And then based on this result, I can look at the front end. So this is basically the top of my application over the last hour. And then I can pick one of these. So this is kind of the timeline of all the traces. I can do all kinds of filtering by time, by the duration. And this tag thing is really useful because I could just say, only show me errors, only show me tags from that particular component in your application. So there's lots of ways to use the search. Then when you pull up a trace, the default view is that timeline view, where here over time we can see the cascading kind of spans that are occurring. The interesting things to note, relatively new feature is what we call critical path. So this black line means that is the part of the entire trace where there's contention going on. So if someone says to you, make this faster, if you speed up things that are not on the black line, it's not going to be any faster. So if I were to go in and try to optimize this particular call or component, it's not going to make a difference. I need to focus on the critical path because those are kind of the longest parts of the trace. It's a really cool feature. Not a lot of other tools actually do that. And so you can kind of see the black lines following here. So there's a bunch of different things you can do here. I can see that this database query is very slow. I can drill into it. And once again, now I see the tags. This is a MySQL database call, and I can actually see that it's a Go application. It's using OpenTelemetry, all of the other data. And then more importantly, from this database transaction, I can actually see some logs that are being gathered by the instrumentation. And this is showing that there was a lock, the lock released, transaction continued. So this kind of shows you how you would do debugging in this case with a database problem. But the other thing I can see here is that there's a whole bunch of different calls to Redis over and over and over. And the worst thing is when you see this staircase pattern, that means that they're not using any threading. So it's waiting for one to finish, next one, next one. If I added threading here, I could probably stack those all up against each other and speed this transaction up. So if I did that, that black line, it would all move over and it would be faster. So this helps you kind of optimize performance, diagnose problems. There's lots of other features in Jaeger. Instead of viewing it in a trace timeline, a relatively new feature is I can get a timeline view. So there's lots of different visualizations for this trace. So the flame graph is pretty cool, but you can also get a graph view. There's lots of other kind of areas that you can look at it. You can also see the raw data, the JSON, basically. And the reason why this is useful is because if you're debugging on your machine, you can actually go and upload a JSON file right here. You can even get this directly from OTel, upload it into Jaeger, and it'll actually visualize the raw JSON for a particular trace. So if one of your colleagues maybe doesn't have access to your Jaeger, you could send them this JSON, and they could look at all the trace data just like you are in your instance. So some people use this kind of like offline in that way, where maybe it's running in a customer environment, and you can get that JSON, you can actually visualize it and analyze it. So it's kind of a cool feature. And there's lots of other kind of views and things that you can get from Jaeger, but those are just a couple of the basic use cases. There's lots of other features here that are pretty interesting and useful. I'm going to jump back, actually, before I do that. I'm going to switch demos because the other one has to generate some data while we are waiting. This one's going to run in the background and give us a bunch of cool data that we can use for the next demo. So I'm not going to go through all of the things that I just went through. I took screenshots in case things don't work. The one thing we didn't look at is the topology view. So this will actually show you how many transactions are going between the different components. This data gets aggregated. Unfortunately, you have to run a Spark job to generate this. It's somewhat annoying, but that's kind of part of the product today. We're working on a way to do this dynamically using OpenSearch in the future. You'll see that in the roadmap. There's a couple people working on it. So that will be better, but you can still do it today and visualize it. We kind of went through the rest of these features already. I'm going to switch gears a little bit and talk about monitoring. So instead of just tracing and diagnostics, let's talk about monitoring. Something we contributed to OpenTelemetry upstream a few years ago. The team in Jaeger built specifically to help us unlock monitoring use cases. So aside from a debugging tool and a diagnostic tool, how do I get operational visibility? A lot of people join the Jaeger channel on the CNCF Slack and they say, I'm instrumenting my service mesh, I'm trying to get tracing data, and all I'm basically getting are metrics because the traces break because there's no correlation between the traces on the service mesh. So what we decided to do was just derive metrics directly from the traces so that you could do more operational monitoring. It's a pretty cool feature. So now Jaeger can either remote write or be scraped so that you can get the metrics from your application. Specifically, these are the red metrics, that's what we call them, request rate, error rate, and duration. So now you actually will get all of that data automatically from everything that's instrumented in OpenTelemetry. And I'll explain how this works. And you can use this whether you use Jaeger or not. It works with any Prometheus compatible backend. So kind of the architecture, when you look at the OpenTelemetry data that's flowing out, the traces, we take those into Jaeger. And then what we do is we basically use this span metrics processor, which emits, it's actually the span metrics connector, which emits that. So it's a component in OpenTelemetry that does this automatically, sends it to your Prometheus, or you can scrape it. And it's useful in other dashboarding tools, whether you're using Perses or Grafana or Jaeger. I'll show you how it looks inside Jaeger in a moment. But it's a really cool feature because you get these metrics automatically. You don't have to do anything. It's automatically derived. So the way that it works in OTel or in Jaeger version 2, which I'll talk about in a moment, this is kind of an example. You can see in the trace pipeline, we basically are calling span metrics as an exporter. So you're kind of taking the traces, sending them to a metrics pipeline, which is then deriving those metrics and sending them out. So it's an elegant way to get that automatically from your existing OpenTelemetry or Jaeger collector, essentially. And then I'm going to show you how this looks in the UI, but this is a screenshot. Let me jump over to a demo. We'll take a look. So I can do the same type of thing where I can view the traces, but we're more interested in this monitoring tab, which I started a few minutes ago. So you can see here that the metrics have started flowing in. I have a Prometheus instance running on my laptop along with Jaeger, and the data is just being populated directly into the Prometheus instance. Jaeger is querying, the front end is querying the Prometheus instance. And then I can view traces that are associated with that. Since this application is really simple, in yours you'll actually have a list of different applications. You could do filtering and you can visualize those in different ways. But yeah, it gives you a pretty nice set of capabilities that let you show kind of operationally how it's doing. So definitely a useful feature. Jump back to this. So a big project that we worked on for a couple of years that was launched officially in November is Jaeger V2. So let me talk about this a little. When OpenTelemetry started, there was no other collector out there. We had Jaeger SDKs that were used to instrument using open tracing, that's the predecessor, and then we had a Jaeger collector. When they started OpenTelemetry, they took the Jaeger collector and used that concept to build OpenTelemetry. Over time, we got rid of our instrumentation. We've moved everything to OTel, and now the second part of this is to actually move the Jaeger components on top of OpenTelemetry. So we essentially re-platformed the entire backend and the processing on OTel, and then we ported over like all of our APIs and other things that were part of Jaeger, and made it completely backward compatible. So if you're using Jaeger version 1 and you install Jaeger version 2, the data repository, the data format, everything will work the same. But it also gives us native support for OpenTelemetry protocol as well. The other nice thing is we have one binary, and now instead of a command line interface that Jaeger version 1 had for config where you could pass all these crazy parameters in, now you have a config file that's YAML, just like OTel. So all of us love debugging YAML. Now you can debug more YAML. So that's what we did here. So the basic idea is that we've essentially built on top of OpenTelemetry the components of Jaeger, and it's a single binary that can act as all of these different roles, so it makes it really flexible. And I'll show you a few examples. We also were one of the first projects to use the new extension capability of OpenTelemetry. So the Jaeger UI actually runs as an OpenTelemetry extension, which is kind of cool. So it lets you do all kinds of interesting things inside the OTel collector architecture. So I'm not going to bore you with the entire config, and those that have used OpenTelemetry can recognize most of this. We obviously have our extensions that allow us to do things that interact with the collector dynamically, so whether that's remote sampling or running our queries. And then we obviously have the trace processing and everything involved there. This is our storage API that we implemented inside the collector. And then you kind of specify your backend. So Jaeger today still supports Elasticsearch, OpenSearch, and Cassandra. I'll talk about some new data sources that we're working on right now. It's part of the roadmap. But we probably have 30 other unofficially supported backends, but those are the ones that we run in our CI/CD. We make sure they work. We support them. If you submit a bug, we'll fix it. We'll look at it. We'll test it. So there's two kind of basic architectures for deploying Jaeger. This is the simple architecture. So you have your applications instrumented. You send it to Jaeger in a collector role. And then we write that data to the database of your choice, OpenSearch, Elasticsearch, Cassandra. And then the UI queries that database and gives you all the visualization that I was just showing you. So this is kind of the basic, like if you're in your dev environment or something small, this will work great. As you scale out and start to get things more complicated, you may have to introduce Kafka to deal with buffering. If you have a huge spike in your application or a lot of traces get generated at once, this will help make it, queue the data, slowly write it to that back end and not overwhelm it. So it's a pretty common pattern. We build Kafka into the Jaeger binary, so you could use it for both putting data into a Kafka queue as well as reading it, which you can see on the right. It can read off the queue and then write to the data store. So that's kind of a more scaled out view of how you would implement Jaeger. The other thing is some of the SDKs in OpenTelemetry have a cool feature called remote sampling, which is only a Jaeger feature. That actually allows you to dynamically change sampling, head-based sampling on the fly, which is a really cool feature. So basically the SDK checks with the collector, it gets the sampling configuration, and then it can dynamically change the application sampling without you restarting it or touching it. So it's a really cool feature, unique to Jaeger. Uber used it extensively, that's why it was built. But it's only supported in a few languages because we have to get all the upstream OTel language SDKs to implement it. So, but it's still a cool feature for sure. So let's talk about roadmap for a couple minutes. I'm kind of going to rewind over the last year. So since I spoke in Paris, some of the things that we did, we launched Jaeger version 2. I talked about that already. The Kafka support is a big ask. We had some challenges and deficiencies in Jaeger version 1. Thankfully, with OpenTelemetry, we have way more capabilities in Kafka, so it was nice to leverage the code of the community versus us having to maintain it. So it makes it so that we can move much faster because we're lockstep with OpenTelemetry versus doing our own thing. We've also officially added support for Elasticsearch version 8 and newer, which we did not have before. It was a common request. There were some workarounds, but now it's officially supported. And then I'll mention that we officially have a Helm chart and a Kubernetes operator, both of which have come out in the last few months for version 2. So thanks to the mentorship programs that we run, we have students and other folks that come and work on the project. The CNCF sponsors them and pays them for their time. And so we use the mentorship programs from Linux Foundation and Google Summer of Code to help work on the project. So the mentorship program specifically helped us with the Helm, the Kubernetes, a bunch of the Jaeger version 2 work, and we continue to use these mentorship programs because they're really helpful. We all have day jobs. We do what we can, but bigger projects, we can guide a student down the right path, and they learn and they contribute. And so it's a great way for us to get more people working on the project. So these are kind of some of the benefits that we get. I'll mention that again in a second when we talk about the roadmap too. So we also have huge amounts of bug fixes. If you look at our release notes, we're always building new things, fixing things, taking all of your feedback, making the project better. We also have had more UI capabilities. So I mentioned the critical path visualization, a really cool feature. Other improvements. There's more work going on in the UI that I'll touch on in the roadmap, but we've added a whole bunch of other capabilities in the UI to improve it. Thanks for everyone's contributions there. So the first thing that is, I would say 80% done or more is ClickHouse support natively, so that'll be official backend for the project. That means we'll test it, it'll be part of our CI system, and if there's any issues, we'll be able to handle it. So that's coming along, it should be done very soon. We have a lot of, going back to the mentorship, we have a mentee right now that's working on a bunch of cool new UI things, modernizing the visualization libraries, making things much more consistent, because if you've used Jaeger, you'll kind of notice that there's 3 different visualization systems because it's evolved over time, since the project is probably about 8 years old, I would guess. So we're really refactoring that, redoing it on something modern, so the visualizations will be much better. And you'll start to get more and more data overlay is kind of the next thing that we're working on. So instead of seeing those metrics separately, now you'll see a graph with metrics on top. You probably get that with some of your vendors, but now you'll get it in open source. So that's a good thing. So we're doing a bunch of different UI things, thanks again to the mentorship programs that help us with that. But we're always open for suggestions, so definitely make your feature requests. And with that, I'm going to open it up to Q&A. We'll have a mic going around, so just raise your hand and ask away. We also have a booth in the pavilions. I'll be there in the afternoons, which is a weird concept because it's not actually afternoon. But I'm there all evening tonight and then part of the afternoon tomorrow and Friday. So pop by the Jaeger booth in the project pavilion too. And if anyone has questions, raise your hand and we'll send a mic over. Anyone? None? Okay. This will be the first KubeCon with no questions. But feel free to come and talk to me after, and I hope you all have a great KubeCon. And thanks again for your time.